All right, now we're going to switch over. We're still going to look at inequalities, but now what we're going to do is we're going to look at rational inequalities. Okay, now glance on that side of your paper there where it goes from 43 to 60. Okay, there's still inequalities, right? Okay, so we could use that graphing strategy. Okay, whatever is above the x-axis is greater than 0, whatever below is less than 0. But let's see, number 43 is your first problem there. So do y'all know how to graph number 43? Do you know how to graph that? Raise your hand if you know how to graph number 43. I do. Okay, so the graphing strategy is not going to work, is it? It would if we knew how to graph it, but we don't. So what we're going to have to go to is a guess and check strategy. All right, so let me lay out some strategies here. Let me put a title here for you. We're going to look at, these are called rational inequalities, and we're saying rational because they're fractions. Okay, so let me just lay out some basic things, and some of this is not really going to make sense till we get to an example. Okay, so just go with me. All right, first thing, just like the other ones, you set to 0. Okay, because you want to say less than or equal to 0, greater than or equal to 0, less than 0, greater than 0. Okay, whatever the case is. All right, second thing, you're dealing with fractions. Now, what you want is you want a single fraction. So sometimes you have to, let's say you make it into a single fraction. Now, most of your problems are going to be already in the single fraction, and they're going to already be to 0. Okay. Now, so that's usually not a problem. Now, when you have to do that, it is a major problem. Okay, that's where they get really difficult. Okay. Now, the third thing, and this is probably the most crucial thing here, okay, is you plot a number line with your critical points. So this is, because we can't graph it, we have to do this strategy. So you plot a number line with your critical points. Now, so what are critical points? We probably need an explanation on that. Okay, so critical points here, what I'm referring to is what makes the numerator and denominator 0. Okay, so set to 0, make it a single fraction. Let's kind of go back to that just a second. It's not a single fraction. How do I take something like make it a single fraction? Add two fractions together, or add a fraction and a whole number together. You have to get, from adding fractions or subtracting fractions, you got to get a common denominator. Okay, and that's what kind of sucks about that. Now, once we get the critical points in our number line, you guess and check on your intervals. One more. There we go. That one was a little violent. All right. So you guess and check your intervals that you divide your number line up into. Okay, now, so what's going to happen, the first few examples that we look at are going to be extremely easy. But when you get down to numbers 55 and 57 and 59, that's where they're going to get really challenging. Okay, so let's start off. Let's do an easy one first. I'm going to do number 44. Okay, now I'm going to change it a little bit in the end so we can kind of make a point about something. All right, they've got x plus 5 over x minus 2 is greater than 0. All right, so do y'all notice that the first 2 points that I made kind of go back, set to 0 and make it into a single fraction, All right, don't really have to do that because it's already set up like that. So now I can go straight to the third step, which is probably the more crucial one, is making the number line. So on the number line, we're going to plot those critical points. So the critical points was what makes the numerator 0 and what makes the denominator 0. So what values would those be? Yeah, -5 and 2. Now, you got to be sure, you got to put them in order, right, on the number line. -5 would be on the left, 2 would be on the right. Now, what I've done to the number line now is I've divided it up into 3 intervals. Okay? You have these numbers to the left of 5, in between -5 and 2, and to the right of 2. Now, this is the way I do it. I label my intervals so I can talk about them. So I call that one A, I call this one B, and I call this one C. Now, what I'm going to do here is I'm going to pick any random numbers here that are in those intervals and see if it would make it true, to see if it would be a solution. So to see if interval A is a solution, I'm going to pick a value in interval A, plug it in, and see if it works. Now, when I pick a value, really what I have to do here when I plug it in, all I have to tell is would it make the numerator or the denominator either positive or negative. Now, a little bit ahead of myself, let's go back and pick a value. So what would be a number that would be in interval A? Negative, what now? 7. Okay, what else would work? -8. What about -6? Okay, so anything like that. All right, let's go with what y'all said there, -7. Now, when you take -7 and you put it into your rational expression here on the left side, you don't really have to tell me what it is. You just need to tell me if it's going to be positive or negative. Okay, so if you put -7 in the numerator, would the numerator be positive or negative? It would be negative. Okay, now put a -7 in the denominator. Would it be positive or negative? -7 minus 2 would be negative. Okay, now we've got this. Now I've got to look at this part. It's supposed to be greater than 0. Now, if that's true, that means all those numbers in interval A are solutions. If it's false, it means that they're not solutions. Now, a negative over negative would be positive. So is a positive greater than 0? Yes, sirree. Okay, it surely is. So that means interval A is a solution. So on my graph, I'm going to shade in interval A. Okay, now let's go to interval B. All right, so what would be a number that falls in interval B here? 0. Yeah, 0 would work. There's lots of numbers in between. Okay, any number that would be in between -5 and 2. 0 is certainly an easy number to put in. Now, y'all put in 0 to the numerator. Would it be positive or negative? Positive. Okay. What about in the denominator? Negative. Okay, now, a positive divided by negative would be a negative. Now, is a negative greater than 0? No. So, interval B, you are not a solution. Okay, so I'm not going to shade in interval B. Now, let's go to interval C. Let's see if he works. Okay, so what would be a number I could test out there? 3, 5, 4, anything bigger than 2. All right, so we put in 3. All right, what would the numerator be, a positive or negative? Positive. Okay, and then the denominator would be positive. So we get a positive over a positive, which would be positive. So is a positive greater than 0? Yes. So interval C is a solution. Move on. Right, we're shading in intervals A and C. So intervals A and C are my solution. Okay, now let's talk about the endpoints. So -5 and the 2. Now, because it's just greater than and not greater than or equal to, then parentheses, we wouldn't include them. Okay, so there's 2 ways to show it on the number line. You could show it with the parentheses on the number line. What else could you show on the number line if you wanted to do open circles? So that's up to you. Parentheses or open circles. Whatever you want to use is fine with me. Now, let's change the problem up a little bit. Okay, so we can have a discussion about something really important. Let's go ahead and change it to greater than or equal to. So since it's just greater than, both of them would be open circles into discussion. Now, let's change it to greater than or equal to. Okay, so be sure you change it on your paper here too. Now, all this stuff really wouldn't change. But what would change is how we would label the endpoints. Now, so now you're probably thinking that we would use brackets or we would use closed circles because it's equal to. Now, we have a big exception to this, and look at me and listen. Look up. Okay? You can never include a value that makes it undefined, no matter if it says equal to or not. Now, what value here would make this function undefined? 2. Y'all get me there? Because that would make me divide by 0, wouldn't it? So no matter what, I don't care if it's got 1,000 equal to's under there. We could never include 2 because 2 would make it undefined. Now -5, he's fine. All right. So we could include -5, but then we couldn't include 2. All right. So now that's using open and closed circles. Certainly you could do it like this. You could have used a bracket there and a parenthesis there. Okay, however you want to do that. Now, ultimately the way we write an answer, that's part of the answer is the graph because it's going to ask you to graph a number line. Now, the other thing is to put it in interval notation. Now, let's just slap that in interval notation real quick. Okay, y'all call it out to me. So start with negative infinity. Negative infinity to -5, bracket, union, parenthesis, to infinity. Okay, now, talk to me. Be sure that you understand this. Do y'all understand why I included this one but didn't include that one? We okay? All right. So remember, you never can include anything that makes the function undefined. All right. Let's look. Really like to look at 46, but I don't think we're running out of short of time here. So let's look. Let me skip to number 54. And what we're going to notice is a pattern here where we don't really have to guess and check as much as you think. Okay, now notice on 54, y'all kind of see how you're going to have more than one critical point on this one? All right, it's already nice and factored for me. It's already set to 0. All right, so what are my critical points here? -3, all right. +2, -1. Okay, I've got to put them in order. Now this time I've got 4 intervals. Now I think for time's sake I'm going to go ahead and just tell you the big secret on guessing and checking. You remember at Stormy what happens? No? All right, look what happened here. A worked, B didn't, C did. Here's the big secret. As long as those quantities aren't being squared, they're going to alternate. Okay, so what happens here? What if we like changed it up a little bit? What if I had like, let's say we had like well, hang on. Start it. What if I had like H, I, and J? So what if H didn't work? I would, and then J wouldn't. If H did work, then I wouldn't, and then J would. They alternate. Okay? So really and truly, on the guessing and checking, all we're going to have to do is check that first interval. Okay? So what's a number I can check my first interval with? Yeah, -4. Okay? So let's put in -4. All right. So if I put in -4, is that one going to be positive or negative? Negative. -4 plus 3 would be negative. Now what about -4 minus 2? Negative. Okay. And then -4 plus 1? Negative. Now all this is supposed to be less than or equal to 0. So let's see if it's true. Now, a negative times a negative would be a positive, and then a positive divided by a negative would be a negative. So we got a negative is less than or equal to 0. That's true. So the first interval works. Okay, so follow the pattern. What's going to happen to the second interval? It's not going to work. And then the next interval would work. And then what about the last interval? No. So it worked, didn't work, worked, didn't work. Okay, they're going to alternate. So you don't, you don't have to really guess and check. Now, do y'all want to take each interval and guess and check with it? I didn't think so. Okay. All right. Now, let's talk about endpoints. Now, if let's change it and we'll change it back. Okay. If that said less than, then all the endpoints would be parentheses or open circles. Okay. No discussion. Now, if it's less than or equal to, some of them are going to be closed, but what's one that's going to have to stay open? -1. Okay, so I could put a bracket here, but on -1 I would have to use parenthesis, and then on 2 I could use a bracket. Now let's put that in interval notation. So that would be -infinity to -3. All right, union. Oh, I messed up. Should have been a bracket. And then union. All right, and then parenthesis -1 to 2 bracket. All right, now let's go down. Let's look at number 58. Tell you what. What time's the bell ring? 40 after. All right, let's try it. I want to go a little faster. I went 1 over x minus 3 is less than 1. Now, when it is not a single fraction and not set to 0, it sucks. Okay? Because you got to do a lot of work here. So I've got to set it to 0 first. That's not that bad. All right, you follow that? All right, but now, how are we going to have to make this into a single fraction? Common denominator. So that common denominator is going to be x minus 3. Okay, now, I'm going to think of this as like -1 or -1 over 1. So when I go from here to here, nothing's really changing, is it? So that 1 in the numerator is just going to come down. Now, what about from here to here? Multiplying by x minus 3. So I've got to multiply this by x minus 3. Now, it's not just 1 times x minus 3, it's -1 times x minus 3. So what would that be there? And -x plus 3. All right, now, let's clean it up. That 1 and that 3 would give me 4. So I'll get -x plus 4. Now, I hate that negative right there. All right, that just drives me crazy. Now, so I'm going to go into denial. Okay, so I'm not overweight and have high blood pressure. I'm perfectly healthy. I'm in denial. So if I'm in denial and I don't see that negative, and we'll cover up, the critical point would be -4 with it, if I covered up that negative. Okay, now, so it's not really -4, but it's going to be +4. That's the way I think about that. Okay, so one of my critical points is 4. What's the other critical point? 3. All right, so our critical points would be 3 and 4. Now, y'all talk to me. Is this making sense here? Okay. Now, let's test. What could I test over here? 2. All right, so if I put in 2, -2 plus 4 would just be positive. And then 2 minus 3 would be negative. So we've got a negative is less than 0. That's true. So this interval is going to work. So what's going to happen with the next interval? It's not going to work, and then the last interval will. Now, it's just less than, so what do we do on the endpoints? Parentheses. Okay. All right, now interval notation here, it's going to go negative infinity to 3, union 4 to infinity. Okay, and like I said earlier, those last three, 55, 57, and 59, those are going to be the tough ones. Okay, all right. Now look what you got over there. You got mostly those odd ones. Not all the odd ones, but a lot of them. All right, I need